Hey everyone, and welcome to this explainer brought to you by Forge College. I'm your host, and today we're tackling something that is absolutely essential for anyone building in this ecosystem. We're looking at connecting to Solana with Solana CLI. Before you can start writing complex code or moving real value around the blockchain, you've got to understand your tools. So our goal today? Mastering the Solana CLI so we can connect securely and truly observe the network. We're going to demystify exactly what's happening under the hood. Let's get right into it.
Here is our architectural blueprint for today. We'll start with a welcome to the network, then break down endpoints, clusters, and key pairs. After that, we'll dive into the post office metaphor, which, trust me, is a seriously helpful way to visualize all of this. Finally, we'll wrap up by tracking your CLI packages and troubleshooting any lost mail. This flows directly from our previous work of integrating Solana CLI with Web3.js workflows, so it's the perfect next step. All right, kicking things off with Section 1, Welcome to the Network. The core philosophy here is pretty straightforward. Before we can build or execute anything, we absolutely must know how to observe. You need to be able to see the playing field. Think about the fundamental operational questions you're going to ask yourself every single day as a developer. Is my RPC healthy? Did the network actually process my transaction? How many confirmations did it get? The command line interface isn't just for your initial setup, it is your primary diagnostic tool. It's essentially the stethoscope you use to listen to the heartbeat of the Solana network. Moving right along to Section 2, Endpoints, Clusters, and Key Pairs. Before we start diagnosing, we need to map out the basic geography of the network and figure out the exact identification tools we use to navigate it.
Let's start with a quick definition. A cluster is simply a collection of validators that process transactions together. You've got LocalNet for your private testing, devnet for public testing, and of course, mainnet-beta where the real value lives. But here's the crucial thing to remember. The CLI doesn't magically know where you want to go. You must explicitly point it to an RPC endpoint to reach your desired cluster. If you don't give it directions, it's not going anywhere.
Now, how do we identify ourselves once we actually know where we're going? Let's contrast CLI key pairs with browser wallets. You're probably super familiar with browser wallets, those slick, user-friendly graphical extensions. CLI key pairs, on the other hand, are simple, raw, file-based JSON arrays of secret keys. And yeah, that might sound a bit primitive compared to a UI, but this file model perfectly maps to server-side development. Your code can read that exact same file to produce identical signatures, making your local development incredibly consistent. So where does the CLI actually keep its brain? Check your profile configurations at ~config/solana-cli/config.yml. This is the exact spot where the CLI looks for those key pairs, and your chosen endpoint settings when it's preparing to send JSON RPC requests on your behalf. It's basically your local command center. Okay, let's pivot to Section 3, the post office metaphor. Abstract JSON RPC concepts can be a little tough to visualize, so we're going to turn these concepts into a tangible, everyday experience that just makes sense. Let's walk through the 5 stages of a transaction lifecycle, just like we're mailing a physical package. Step 1, prepare. You get your block hash and instructions together. You're boxing it up. Step 2, sign. You attach your cryptographic signature, essentially sealing the box. Step 3, submit. You send it to the network, dropping it off at the post office. Step 4, confirm. The network processes it, so your package is in transit, moving between delivery trucks. And finally, Step 5, finalize. Rooted by consensus, meaning your package is officially delivered and signed for. And the coolest part is how this maps directly to your tools. Your cryptographic signatures, those are your tamper-evident seals. The RPC endpoint URL you configure is the local post office drop-off counter. And those confirmations, that's exactly like frantically refreshing the package tracking updates on your phone, just anxious to see if your highly important delivery made it safely to the next sorting facility. Speaking of tracking, let's check out Section 4, tracking your CLI packages. We need to know the exact practical commands we're going to use to trace our digital mail across the network. All right, here is your essential engineering cheat sheet. First, Solana config get. This checks your active RPC and key pair. Use it before any query. Next, Solana ping. This tests RPC responsiveness, which is great when the network feels a bit sluggish. Then there's Solana slot, which checks the cluster's slot height to verify the network is actually producing blocks. And finally, Solana confirm is your go-to for a quick status check on a specific transaction's confirmation level. I really want to highlight this quote because it is a fundamental best practice. Always verify Solana config get before running diagnostic commands so you are querying the intended cluster.
Honestly, think about it. You do not want to accidentally send your testnet packages to a mainnet post office, right? Checking your config first takes literally 2 seconds, and I promise you, it will save you hours of absolute confusion.
When you track that package, you'll see these specific status updates. Processed simply means it was accepted by the RPC. They scanned it at the counter. Confirmed means it's included in a block. It's officially on the delivery truck. Finalized means it is rooted by consensus and it is permanent. Now, early transit states like processed or confirmed are totally fine for rapid local testing. But if you're building production flows that move real assets, you absolutely need to wait for that finalized delivery receipt.
Now, what happens when things inevitably go wrong? Let's dive into Section 5, Troubleshooting Lost Mail, and see how we can systematically fix things when they pop up.
When a package fails to reach its destination, this is your heavy-duty command. Solana, transaction, followed by the signature, and then dash output JSON. This pulls the full instruction logs right from the network. It's essentially like demanding the Postmaster General hand over the exact routing history and failure report for your lost box. It gives you the raw data you need to figure out exactly what happened.
When you read through those logs, you're going to see two distinct classes of errors. On one side, deterministic errors. These are rejected right at drop-off, like a bad signature or a missing account. You basically forgot to put a stamp on the box. For these, you must manually go in and fix your code. On the other side, transient errors. These are just delayed in transit, like an RPC timeout or heavy network congestion. The fix here isn't changing your code. It usually just requires a bit of patience or pointing your CLI to a healthier endpoint.
So, here is your straightforward action plan for debugging. Number 1, inspect the error field in that JSON output. Number 2, review the instruction logs to get context on exactly where it failed. Number 3, make your decision. Do you need to re-sign and fix the transaction, simply resubmit it and wait, or completely switch your RPC endpoints? By the way, if you find this whole debugging process fascinating, other Forge College learning programs dive way deeper into advanced transaction debugging and node operations.
Which brings us to our conclusion. Your local post office is open, your configuration is totally dialed in, and your signature is sealed. So are you ready to send your first true transfer? Because now that you know how to observe the network, you are fully prepared to start changing its state. Thank you so much for joining me for this explainer. I highly encourage you to head over to forge.college to learn more about the subject and explore our extensive library of other Web3 related topics. Keep learning, keep building, and I will see you next time.